Hello, everyone. My name is Patrick Matthews, and I'm responsible for the EV solutions for the automotive group of ABB globally. And I'm really excited to be here today to explain to you ABB's offering in the electrical vehicle market. So I'm really excited to kind of show you some of our solutions, some of the things we do, what we've been doing, and where we're going to go in the future. So with that, I would like to start forward. And we'll talk a little bit about the transformation of ICE or internal combustion engines into EVs. Okay. We all heard about this transition from the current gasoline or petrol or diesel car into EVs. And the exciting thing about this is it's here. I can tell you today, there's a tremendous amount of CapEx spend by our automotive customers. Asia's been leading the way. Europe's closely following behind that, and the U.S. is a little bit slower to that as well. So what we see is no more are we going to see the muffler systems and the fuel tanks and the internal combustion engines with pistons and crankshafts or transmissions that are really complicated that have to go forward and reverse, and even the axles. What we're moving to is a platform that's really based around a battery pack, electric motor, whether it be a front drive or rear drive or single motor, and then controllers that really run the drives and run the motors. Um, and we're seeing this transition right now today. We have projects going on in all of these areas, and we have many solutions to offer in this, which we'll kind of go through some of those today. The real focus for ABB and why ABB is we're here to really reduce our customers' risk and come up with a common process, common designs that we can then replicate in each of the regions around the world. And we're going to talk about what those are, those flexible, modular, cellular based systems that we have been deploying around the world right now. So as we move into the next piece of this is a little bit about ABB and the whole value stack or value pyramid that we see for our customers. Okay. And what's really important here is at the very base, what really makes the foundation of the pyramid or the value stack is really our robots, our software, some of the packages, peripherals, track motions, AGVs. That's the bottom. That's where we build on. Okay. And then as we go up the value and we increase the value for our customer, we see the functional modules. Those are things that maybe a customer would do their own add-ons, or an integrator could take and do add-ons that could add more value into the customer's solution for the ultimate product that they want to develop. And then as we move one step further, we got the application cells. These cells are standalone. They can be standalone cells. They can do particular things. They can be integrated into assembly systems, but they're standard cells that have the process that completely produce the part or whatever they're intended to do. And then as finally we move up to the top or the top of the pyramid, we really have the full system or the smart system that's really based on built-in, based on all those building blocks below it, the application cells, functional modules, maybe our robots, our some of our peripherals, maybe the software we got. So that's the ultimate solution to the customer is what we generate there. And those two top pieces are what we're primarily going to talk about today. We're going to touch on some of the other ones, but that's the focus of the presentation today. I don't want to lose sight, though. We hold that pyramid in and really encase it, though, with our service business, which you see on the left-hand side. Service is really important on our solutions at all levels, at our basic robots, at our functional module, all the way up to our systems. Service is very, very important for our customers. And then don't want to lose sight that really we have the new wave coming of the software in digital. That is really becoming very important. Robot Studio, the digital twins that we're building, the whole software that's put in there to really make and give the machines and or the functional modules, whatever it may be, that whole usability effect. That's where we really encase our software and digital system. So this is our whole value stack. What we're going to do today is really talk through some of these applications more on the system side of it, and go through and show you how and what we've been doing with that. If we step back and look at EVs, and what's the real basic building blocks of EVs, okay? So you have batteries, which are made up of a number of things, and you have drive units or electric motors and transmissions. Those are the two principal building blocks of an EV, or the major differences there. Now, there's other things out there for sure that are different, but these are the driving underlying differences. So if we take batteries, typically at the very basic level, you have cells. Okay, and they could be a cylindrical cell, it could be a pouch type of cell, it could be a prismatic cell. Those are just the different cells that would go into building that battery. Okay, as we move to the left a little bit, you have the modules. They are typically built up of cells. They can be somewhere 15 to 25 or 30 prismatic cells, or as many as 600, 700, 1100 cylindrical cells or pouches, depending on the range, depending on the customer's configuration. So the modules are really there to take the cells, put them in a package in a little bigger format, and then they would go into what we call module to pack. Okay, which is typically how it's been done to this point, which is where you really take those modules and you start to place them together and really build the pack, the battery per se, for the electric vehicle. And you can see that sometimes those battery packs are in the configuration of the vehicle or what would fit in the vehicle. Some they're single level, some they're dual tiered. There are a whole myriad of different arrangements on how that battery pack looks like. And then as we move a little bit further to the right, we see cell to pack. Cell to pack's a new technology coming on. It really takes and eliminates the modules. So basically what you're able to do is take cells and bring them right into the pack. And why would you want to do that? One, you eliminate the module, you eliminate the cost and the pieces that are associated with it. And when you do that, it can give you a little bit bigger battery density. Maybe you could use a little different format of battery makeup because you have more density and you can get those in there. And most importantly, now you can start to make that whole battery tray structural member. You can actually have the cells and the battery tray become a structural member of the vehicle. And that's really going to be important in the future. Then as we step over into the drive unit, so kind of a little different technology. This is where the battery gives it its energy. It also then feeds back energy into the battery to charge it and for regenerative purposes. But in that drive unit, it's really made up of three basic things. You have the electronics, which is a battery or drive motor controller. And that's really to give the drive its characteristics. How does it turn? What's it doing at low speed, high speed, all of that. So a lot of electronics in there, much like a standard drive that you would think on any servo drive. And then you have the e-motor. E-motor is it's typically, they're made up of rotors and stators. They can look like in this picture, which looks like a small servo motor, or they can look like a traditional ICE or petrol engine, but just have completely different insides to them. But they are all typically made up of rotors, stators, and then other units built around it. Then you have the e-transmission. These e-transmissions and e-axles, the e-transmission, if we stick with that for now, that is a much simpler set of a transmission than we think of the old traditional ICE transmissions. It's typically a gearbox or gear reducer, has many less parts in it, okay?
And what you see, and that's really fundamentally for one reason, a gas or petrol engine starts up, it runs, 600-700 RPMs until you give it the gas. It then continues to rev and turn. It always turns in one direction, and it's always turning. So the transmission had to take care of reversing. The transmission had to take care of that always spinning. In an electric vehicle, you don't have that. That electric motor can stop, it can reverse, go the other way. It can go, it can stop, it can hold, it can do all those things. So what we see is the e-transmission is really a much scaled down version of what we think transmissions are. It's really fundamentally a gearbox. And then you have axles. E-axles are out there. They're not so much in passenger cars. They're more so for probably in the heavy truck industry and stuff is where we see those coming. So what we want to do next now is I want to talk a little bit about how ABB is structured and what we're doing and some of the systems that we're building. And then we're going to go right into some of those systems in each one of these areas. So as I take on to the next, you're going to see as I alluded to in the very beginning, ABB wants to build standard solutions, good solid standard cells that are repeatable, and we want to try to replicate those around the world as our customer needs. For sure, they're going to be customized to whatever the product is, but the basic building blocks should be similar and should be much the same. That reduces risk. So what we have is our 5 different lead centers. We have Germany and Europe, where we're doing our batteries from. We have Spain, which is really more for what we do our final trim and assembly, which we're not going to talk too much about today. And then you have France, where our e-motor for Europe comes from. And then in China, in Shanghai there, you see that we have our China facility, which does e-motors and batteries. And then, of course, North America, we again do e-motors and batteries out of there. We've split up Europe. That's where our competence is. That's how we grow and push that forward to the market and really serve our customers at a higher level. If we look now, what is ABB's vision? What do we want to sell to our customers? What is it that we're really pushing? We think flexibility is really, really key in this market. It's going to be very, very important to future-proof. We know the products are changing. We know the volumes are changing. So what we've come up with is a solution that really wraps around our ABB technology, our robots, our safe move, maybe some of our particular products or function packages like fire protection, end-of-line testers. We take that ABB technology and we build them into modular cells. And those modular cells are just what they say. They're basically standalone cells, okay, or islands that can run and function like they can. And then what we do then is arrange them in both configuration of where they're at and quantity for future volume increases or future volume decreases. We arrange them in a flexible assembly line that really can be scalable. It can use a AGV-based transport system. It can use conveyor-based, can be used robot-based, but they're standard flexible modular cells that are basically standalone identities that can really function together with those transport systems. So this is that highly flexible solution that we at ABB have really started to put into our systems. If we expound on it a little bit, here's a typical battery assembly line. So what this system does is we take the input from the customer, we look at their product, we look at the requirements of their product, we then look at the volumes that they want to do, we look at the testing that needs to be done. And while every battery is pretty close, there are some minute differences between them. And what we do then is we say, okay, this would be the basic backbone or the framework of the system. And we would do it AGV based or we do it conveyor based. But we build that. And then what we do is we look at the left, we take standard stations. You'll see like a flow drill station for putting the covers on. You'll see manual load station for wiring. And maybe you have 4 or 5 of those and you put those either in a what we call parallel which basically they're completely parallel, one next to the other, or they can be in series if it's required, or they can be what we call stitch parallel, which is basically you pass one through to the other. And we do that same thing on the rest of the modules that really build up this system. So that's the key to building a flexible cellular-based modular assembly system. It's really taking those individual pieces and putting them together and connecting them with an AGV or conveyor-based transport system. And what really then drives that is its ability to scale up and down. And we'll talk more about that through some of the solutions that you'll see here in the future, in a few minutes. So if we go back to that basic building blocks of what an EV is, what I wanted to do is share with you in each one of these areas what ABB is doing, and in some cases what we're not doing and why we're not doing it. So if we take the battery and we look at the cell, you'll see the cell is typically high volume, meaning that is, you're going to run 5, 10, maybe even more per second, okay, depending on what they are to build the volumes of the future EVs, okay? If you imagine this, if you have 1,100 of these prismatic cells in each module, and each module has there's 12 modules in each vehicle, you can just imagine the amount of scale that you got to do. Also in the cells, we see that that's some technology, the winding of the coating, the slitting, the whole electrolyte, the forming, charging, discharging of the cells. Those are all really, really traditional battery, even the old school cells that we use in our mice and our anything that we use. Those are technologies that were born out of that industry, and there's people that have that industry and they know those particular equipment very well. What ABB is good at is we're good at automating in between those processes, or really sorting at the end of that process. And that's what I want to share with you right now in the next slides, is what we're looking at. So what you see here is from our B&R group, we think the B&R Occupos track is a really solid product for interconnecting in the cell process area. And why is that? The Occupos track is very fast. It's very flexible, okay? It can marry up and coordinate 3, 4, 5, 6 units at a time. It can go, it can be diverting, it can sort, it can do all those things. And more importantly, it's flexible. So what we think is in a lot of those interconnecting in the cell business, the B&R Occupos track gives some really big advantages to that. And if I share with you, I wanted to share with you a little video of that. So here's a video that you'll see of what that tracks. So here you see a battery cell moving through an Occupos track configuration and assembly system. So you'll see that this is very high speed. You can marry them all up. You can put small trains together. You can then break them apart. It's very, very flexible on how you can really do that. And most important, it's high speed. That's the key in the cell manufacturing of EVs, high speed in the cell. So what is it we would do with that? So here's a solution that you see here. This solution here is based on the Occupos track. It's using the Occupos track to really take cells that came out of formation. And formation is a process that each of the cells have to go through after they're put together and they're charged with an electrolyte. Then what they do is go into massive storage facilities, typically temperature controlled and fireproofed, okay? And what they do is they stay into that storage for sometimes more than 20 days, sometimes less. And they get charged, discharged, and you're really forming that cell. But the cells don't always form the same, okay? So what you see is some are better than others. And what this system does, it allows you to separate those cells. It allows you to really, we know what the grading is that came out of formation because they've tracked that and they've given us a tray. What we do is pick all those individuals cells out of those trays by their grades, and then we use the Occupos track, okay, to separate those and marry them up in smaller trays. So now we can start to handle 10 or 12 of them simultaneously. So then we can then move them onto the pack out cells at the very back. And this could go from a cell manufacturer within a facility, and then it would be taken over to a module or a cell to pack line, or it could be in a different facility and it would then be transported to various other automotives. So what you'll see this system is it has a lot of use of the Flex Picker IRB 360 robot, and we use that for speed. Okay, so we have very high speed and they just pick and they load it to the Occupos track. The Occupos track then sorts them, okay, and then builds trains of them to where we can pick off 10, 15 of them at one time. And that allows us to run that same throughput, that high volume of the amount of cells with a more traditional handling system that both us and our customers are used to. So this is one solution in the cell manufacturing that ABB offers, okay? If we move further now and we get into the modules, okay, and modules are becoming more and more important. We're seeing a lot of our customers are very, very interested in the cell to pack. And as you can imagine, if you're going to go from cells into modules, the same process has to go from cells into cell to pack. So the welding, the stacking, the thermal paste between the cells, they're all going to be similar in there. And that's why we're seeing a lot of renewal interest in how do you build modules, not just receiving them from a battery manufacturer and then configuring them in the pack. So as we jump into the module build a little bit, I wanted to show you really what they consist of. Here, what we're going to show you here is one particular prismatic battery. This is a module. It's for trains. And what you'll see is the modules here are stacked in certain orders. There's dividers, there's different separators between them. Sometimes there's computer boards for battery management that are placed into modules. But what the largest single thing of most of the module production is the welding of the tabs. How do you connect the anodes and cathodes? And that is principally the largest CapEx spend in there and the most amount of machinery usually in each of the module assemblies. So what I wanted to share with you here a little bit in this next video is what a typical module to pack would look like. So here, what you'll see here is a typical cell. You'll see the modules coming in here. They're just in containers. So we now pick them out with a robot. We then load them into a configuration. You can have multiple configurations. I think this particular cell has 3 or 4, okay? And you'll see the red and the green or white tabs that are on the top. That's so to get lined up for the bus bar connection when we weld. We now then load it to a traditional turntable, arc welding, laser welding style package that we have produced. That's one of our standard cells that our systems have built. And then after it's completely welded together, we then, in this case, manually build it into a battery pack, okay? That's typically the whole pack building or module building process that goes along. This is a very limited piece of it, but it gives you a good insight into what module build is about. As we move forward, I wanted to get into the module build. And this is where a lot of the our customers are focused on right now. This is really gives you the configuration of the vehicle. It really sometimes is the whole floor of the vehicle. And this is where a lot of that comes. We're not going to talk cell to pack today, but you can imagine that cell to pack would basically be combining those things that we just saw, okay, into this same process. So what you'd see is a much, much larger scale of equipment. You'd see a lot more of the welding. You'll see a lot more of the handling of the cells that would come in instead of just picking modules and placing them onto that. So what I wanted to do next is really talk about what's the major pieces in these battery packs. I get asked this a lot. Well, what is a battery pack and what does it look like? Well, battery packs are typically made up of trays or a aluminum or a steel base, okay, that's been precisely machined and or cast. And what you then have is a cooling plate, either integral or a cooling plate that is added in and bolted down. That cooling plate really is meant to take the heat away from the module, or in a cell to pack, the cells. And what there is there's typically what we call thermal interface paste. That thermal interface paste is been done by pads with stickies on them, or now we dispense it robotically, but that paste is quite a difficult paste to apply. And it's much like the Microsoft or the microprocessor to heat sink that we used to all put on. If anyone has ever built a computer, that's this paste. And you have to have it distributed very evenly across there, or you create hot spots in batteries, and that's not a good thing. Next, there are the module load. You actually then have to put the modules in, and you have to put them down into the thermal interface paste, and then you have to bolt those on. You then have the interconnect, the bus bars between the wiring, between each of the modules. That's how you connect all the individual pieces of the battery together. There also very well could be a battery controller inside the battery pack. Some are outside, some are inside. You would put that battery control box in there, and you have to interconnect to that. And then, of course, you always have lots of brackets. You have the connectors. You have all those pieces, those ancillary pieces that can come on. Sometimes they change per vehicle. Sometimes they're cast in. It really depends on the customer's product. And lastly, and probably the most important thing, is basically the cover. What goes on top of this battery after you put the modules or you build a cell to pack? What do you put on top of that module, and how do you seal it? Because remember, this is on the underneath of your vehicle, and it's going to be out in the harsh, nasty environment, water, rain, snow, depending on where you're at, and you've got to completely seal this battery up. So that's what you'll see is a cover. Many different types of covers. Some are steel, some are flat, some are aluminum, some are composite materials. We see it all. So cover put to placement and how you affix it is very, very important in the production of a battery module. And then lastly, you have to test it. So after you put this together, there's typically, when you put the modules and the battery controller, you typically do an in-process test to make sure everything is hooked up right, okay, before you attach that cover or glue that cover. Some of them are glued on now, and they're very difficult to get off afterwards. So you want to make sure everything is proper, everything is done correct before you do it. And then there's the final test. And that final test, there's a couple of tests that typically go on there. One, there's a leak test. You got to make sure everything is leaked, and not only leak tests for the cover and the battery, but maybe even the coolant systems, okay, that have to go on through the battery to take away the heat. And then far and away, the biggest piece of it is the charge discharge, really to bring that end of line cycler testing and bring that battery into its full charge it's about 80% charge when it leaves typical assembly lines. So you charge it up and discharge it to make sure the battery is working good. And at that time, it's ready to go to the vehicle assembly and be put in the vehicle. So these are the typical steps in a battery. I want to take you now through a battery system that is one that's modular. It's highly robust. It's got a lot of robots in it. It runs about 44,000 units a year. There's, I think, 8 robots in there in the system, and it's very much a typical battery assembly system. So as I bring on that video of this system, I would like to talk through that a little bit. So what this system does is you see these 2 high-lows down in the very center, very bottom of the picture. Those high-lows are taking finished batteries out on the right-hand side, and they're putting battery trays in on the right-hand side. And we have one robot on a track loading these new battery trays onto the AGV e-cart, and then we have that same unit pulling finished batteries off, putting them in dunnage to leave the system. So as we continue to follow this line around and we go down to the cell on the very bottom right, okay, what that is module load. You'll see the 2 high-lows that are bringing in product into the very left-hand side of the screen there. They're bringing in modules. Those are modules where you're picking those modules all out of those dunnage. There's 2 robots on track. It's using 3D compliant grippers to go in and pick those modules up. And what they do is then they pass those off to handoff tables. They don't put them directly on. Those handoff tables then do the alignment, get ready for the screws that have to go in there, and they then get attached and loaded into the bottom tray layer of this particular battery. And then they're affixed with 4 bolts that hold each one of those arrays down. We then leave this cell. We go to 3 different manual stations, which is up on the top left-hand side there. Those 3 manual stations do all the interconnect of those battery modules that we just placed in. It then comes back into this same cell, and you might go, wow, that doesn't seem right. But this particular battery has what we call a penthouse, or a double layer. So there's 4 cells that go on the very back of it. It's bumped up. And what we do is we go in and use the same automation that loaded those cells. Instead of duplicating it, we use the same one with those handoff tables, and we have a robot that goes and places those 4 cells on top of that battery in the penthouse configuration, and again, tighten the bolts down. It then leaves this cell, which is in the center area. It goes through interconnect manual to hook up those bus bars, and then it leaves and goes to, in the very center on the top of the simulation here, you'll see a bunch of 5 cells with manual. That's the in-process test. That's making sure all the connectors are hooked up right, everything is good before we put the cover on. Okay, because this particular cover is glued on. And when it's glued, it's very, while it can come apart, it's very, very difficult, and it's certainly messy to get if you had to get in there and make any changes. So that's what you see in the upper right hand corner. Those cells there, what they're doing is they're taking the top cover from dunnage. They are then placing it through a plasma cleaner to clean out that plastic carbon fiber cover. It would then put a primer on it. We then store it in a storage cell for primer for a bit. And then after the primer is set, we dispense a glue on it, okay, with a robotic dispensing around the glue. We then go place it on top of the battery pack, and then we secure it with only a few screws, because this battery pack is glued on. So then it leaves this cell and it comes to 2 more manual stations. This is where we hook the interconnection. So this is actually the cover where all the connections of the battery to the motor, the battery to the rest of the subsystems of the vehicle, that's where that bulkhead connector gets put on. It then comes to one of the final stations, which is basically the final end of line test. But before we do end of line, because this is a glue-on cover and it's not a gasket, we actually have to let that glue sit for a bit. Okay, it's got to sit for time, or if we charged it with air and tried to find a leak, we'd just be blowing the seal out or making it worse. So what you have is a baker's racks where we hold those, and a robot basically keeps those fill. And when it's in there for the set amount of time, it comes into these end of line testers where we go in, hook the battery up, charge it, discharge it, verify it, do all of the cycle testing on it. And then it leaves and comes to the pack out area where we actually then put it in dunnage and it's ready to go to the automotive final trim and assembly building. So this is a very, very typical battery assembly line that we have built. As I move forward, I want to get into battery drive modules. Battery drive modules are really important. They basically give the drive unit what its controls, how to act, how to do the regen, all those pieces of that. And what you'll see here is a typical battery control module. Again, a lot of use of the IRB 360s and a lot of loading of product in. These cells have a lot of product that comes into them, and we use the flex picker and we use then traditional assembly processes to put these battery control modules together. So what I'd like to show you here is this is a standard cell we built. So you'll see the IRB flex picker. He's loading parts out of trays, putting them onto a pallet, which contains the part, and then it moves down to the next station, which is a robot that would either do more work on it or it could be doing the fasteners. Okay, so these are kind of standard building block segments that you could put together. And if you have a lot of these, you can put 4 or 5 of these together, have different incoming product, and then really around a conveyor system or an AGV system, you can use this as a building block. And what I'd like to show you real quick is a quick video of what those look like. And that is right here. So this is a standard cell. You'll see the IRB flex picker robot. It's picking up the parts out of tray. It's reading barcodes. So it's understanding what it's getting. And it's also writing to the pallet tag exactly what it's got. And then you'll see it leave and go to the next station, which is basically screwing on those pieces that we just added on. Okay, there are other applications after this where we would maybe roll on insulating film between them or do some assembly in that station. But this is a pretty typical station for us in battery control module build. As we continue on further in our journey through EVs, let's talk about e-motors. This is probably the biggest area and that we're going to get into. And what I really want to tell you a little bit about the e-motors, they're basically made up of 4 different features or 5 different parts. You have the wound rotors, you have a magnetic rotor, you have one or the other, and they typically depends on the product design of the customer. You then have in the center there the EV engine. And again, I said that they could look like a servo motor or they can look like a gas engine. Okay, it really is dependent on the customer's product design. You have a motor drive controller. Some of those are attached to the engine. Some of those are externally attached. You then traditionally have a gearbox, okay, that would be put onto the motor and tested. And then inside of that motor, every motor has either a stator, which is either a hairpin stator or a wound stator. And our focus today has been on the green pieces. And I'll tell you why. We add a lot of value in those. We have processes around those. We've built standard cells to do those. The yellow pieces, the wound stator, the wound rotor, the hairpin stator, they're very much based on really high highly skilled winding machines, okay, that are not traditional to what ABB has done. And what we have found and decided that is we go through partners. So if a customer came to us and said, hey, I want you to build the whole EV engine and I want everything, we would do that. We would do, if it is a magnetic rotor, we would do that system completely ourselves. We would certainly build the drive motor. We'd certainly build the EV engine line and the gearbox. But if it was a hairpin stator, we would probably go to a partner. It's just technology we don't have. And most importantly, that technology is changing quite a bit. And you need to be in that industry to really do it. So we drive those through partners. But we can be the value-added integrator if wanted, or we can be the individual part suppliers as these. So let's get into EVs. So let's or motors. Let's look at a magnetic rotor. You saw that I said we're really we want to do magnetic rotors. So what we see here is this is a magnetic rotor. They're typically made up of different slices, okay, and there's magnets put into each one of those. So what you see here is a small video of this. And I will bring that up right now. And what you'll see is we're using a small robot with a gripper. We're using a traditional ABB turntable from one of our arc welding products. The grippers, and this can be a completely flexible system, okay, for different stack heights, for different rotor diameters, for different magnetic spacing. So that's the real value for us in this piece of it. If we move back and continue forward, we're going to look at, this is a typical magnetic rotor assembly system. And this is building up those stacks. So as I bring this up and you watch it play here. So this is a typical magnetic rotor. You'll see the two small robots down in the lower right-hand corner. They're loading magnets, and they are just all day loading magnets. In this particular system, they use force control to load those magnets. They're on a turntable, again, highly flexible solution. You'll see the large robot in the center. He's basically grabbing stacks from incoming conveyor down on the lower right. He then loads them to the magnetic stackers, and then he will also take them and stick them in these big blue doored items, which you see on the top left-hand corner. And those are ovens. We actually heat this part very hot, and after it's heated and it's hot for so long, we take it out of those ovens and we go into a process which we call transfer mold. It's a lot like injection molding. What we do is take a pellet of material that's been preheated. We put it into a servo-driven injection mold. We put a runner plate on top and bottom, and we compress that under very high load into that very hot part. That then hot part sets that glue, and it completely encapsulates all those magnets in all those different cavities. And that way it's completely secured inside there. We then take the plates off, and then we load this out to, and we've built a magnetic rotor stack. If we continue further, we then look at the next typical rotor cell, and this would be for either a wound rotor or a magnetic rotor. What you'll see here is a cell that we've done in a digital twin, okay, in process simulate system, okay. And what you'll see here is a system that really is using two robots in conjunction. You'll see the large robot is picking a part out of a balancing machine. So it's balanced, it's putting another part in it, and then it will load it on the outgoing conveyor, okay. But the small robot, what it's doing, you'll see pallets running around. That's a kit line, and those pallets are just bringing the parts to these two robots that work in conjunction in tandem. And what you'll see is rotor stacks. You'll see the small robot just put a shaft into it. This could be a press station. It could be a bolt-on station. It can be either one of those. And then you'll see another cell over in the middle, much closer where the small robot just loaded a part to. And you'll see that that's where we add bearings on, we add an exciter ring on. And what this whole process does is it finishes the build of a magnetic, or in some cases, a wound rotor, puts the shaft in, puts all the right pieces to get it to go to the final engine assembly line. And as we go to the final engine assembly line is what we're going to talk about next. So in a final assembly line, the key to these stations are really marrying the stator and the rotor. You typically you have housings, you put the stator into the housing, you then build some pieces around it, whether it's a small water pump or an oil pump for the gearbox. It has certainly a bunch of different connection points to it for the cabling and stuff that has to charge it. It could have the battery or motor control box mounted to it. So what this system does is it completely then assembles all those. It puts the stator into the housing. It puts the rotor into the stator. It then puts both end caps, and typically one end cap is the gearbox. Okay, it puts the gearbox in them. It then buttons up the gearbox. It then will put oil in the gearbox, and then it will go through an NVH and final test machine where we completely run and test it. Okay, and that's what this system does. What I want to share with you is, again, around that whole building block structure. We really push and build the building blocks for the structure, and that's what you'll see here. These are our standard building blocks. I want to move very quickly on to one of the last videos I have for you. And this particular video is that rotor marriage stator. And here what it's doing is you'll see a robot, again, modular assembly cell. The system, you'll see it picking a part off the assembly system over on the very back. It's loading a bolt into the case here. It loads the case into the tooling. It will then go and switch its end effector. It'll pick up the bottom cover, because we have to put the bottom cover on this one, and bearings. So you'll see it's changing its end effector right now. It will go and grab the bottom cover off the pallet of the main line. Okay, and you'll notice this is all offline. This is not in the line. Okay, we then load the end cover into the tooling. We'll then go and change the gripper again, and we'll then pick up the rotor, put it and then put it into the tooling, and then we'll together bring all three of those parts simultaneously together. And this is one of the key stations in the assembly of electric motors, is how do you bring those really three key pieces together. So here it's putting them. We hold the rotor in centers. Okay, and then what you'll see next is it will go bring all three together. The robot is changing its end effector now, and it will get to ready to take the final part that's been completely assembled and put it back onto the main line. If I move forward, what I'd like to show you next is a little bit of that scalable modular assembly system. So what you see here is a battery pack line for 5 JPH. And what I want you to see by clicking forward and back, you'll see this is that advantage of modular assembly. So with this assembly line, you can double the output of the line by adding these extra stations in there. And that's really key. And vice versa. If the assembly line in a couple of years needs to reduce its volume, our customer could take that asset and remove it and take it to another plant or another system. This is the advantage of flexible modular assembly lines. Last but not least, I want to kind of go through the robots in assembly. You saw many robots. You saw many of our solutions. We have integrated dispense packages. We have the ABB Flex Cycler, end-of-line tester. We have our track systems, ABB conveyor, our Occupos track. We have that transfer mold process, what you see. And most importantly, now we have AGVs. So if I finish up, what you'll see here is the whole technology landscape. We go from body shop to press shop to body shop, material handling, paint shop, powertrain, and final assembly. That's the whole life cycle of a vehicle. You'll see the robots, and we package that all around our standard products, robots, B&R, and our OSTI conveyors, or AGVs. So with that, I'd like to say thank you and open it up for any questions. So, any questions? Looks like we have nothing yet. Any questions at all, guys? Oh, I think we have a question. What do you see the biggest challenge facing EV solutions? Oh, great question. It's probably how do you scale? How do you have that flexibility? Our products are changing. Our volumes are changing. It's really easy to build these things, a couple at a time. But now we got to build 300 or 400 of them at the same time. How do we change that? How do we scale it? And how do we really make that scalable so we're future-proof in our business? Another one, is ABB supplying all the stations that you showed in the videos, or are they from integrators? Most all of those stations you saw in these videos are ABB stations. In fact, I think every one of them were. Okay, any other questions? Guys, just to finish up, if there's no more questions, please reach out to your sales teams, to your local teams if you have questions. It's really important to get them out there. We really would like to, answer all those and support our customers and our sales teams throughout the world. So if you have any questions, just reach out to the ABB assembly teams. And with that, I think, if no further questions, it doesn't look like anything else coming in. I think we can finish up. 5 minutes. So I'll give you guys 5 minutes back. Okay, thanks everyone.